Let's simplify this rational expression. So in the numerator we have -8. That's going to be squared. We have x squared times 2, y cubed times 2. And in the bottom, we're looking at 4 cubed, x to the third cubed, and y cubed. Let's simplify. -8 squared is 64, x to the fourth, y to the sixth. On the bottom, 4 cubed is also 64. That's x to the ninth and y to the third. So the 64s are going to cancel, and I have y to the third in the numerator, and in the denominator, x to the fifth. And that's as good as I can do. Today's lesson is section 11.1 in our textbook, adding and subtracting polynomials. There will be a lot of vocabulary involved, and then we'll do some arithmetic with our polynomials. We want to be able to describe them in terms of their degree and number of terms, and then of course we'll be doing some adding and subtracting with them. First of all, what is a monomial? Well, it's an expression that's a number and a variable, or a product of the two. Some examples. The degree of a monomial is the sum of the exponents of its variables. For a monomial with no variables, we call that a constant, and the degree of that guy is 0. Some examples: 2x squared y to the third, that's a fifth degree monomial. -12a, that's to the first power, so that's a first degree monomial. And 5bc to the third, that's 1 plus 3, or a fourth degree monomial. A polynomial then is a collection of monomials, where they're added or subtracted. Some examples of these guys. The standard form of a polynomial means you're writing it in an order so that the degrees are descending, so from highest degree down to lowest degree monomial. An example: x to the third plus 2x squared minus 4x plus 5. The degree of that polynomial is the highest monomial, which is a third degree polynomial. Let's go over some terminology here. Actually, let's do an example where we write it in standard form, and then we'll get into some terminology. We're going to write the degree of this polynomial after we've put it in standard form. So this 5x to the third term, that cubed, is going to need to come up towards the front, and this constant is going to need to go into the back. So we would rearrange it and write it as 3x to the fourth plus 5x cubed plus 2x squared minus 4. Another example, this fourth degree term goes up front, so -9x to the fourth. We're going to add to that 6x squared, and then plus our constant in the back, 7. Now let's do some terminology. Let's describe some polynomials in terms of their degree and number of terms. This is a first degree polynomial, so it's a linear. There's 2 terms, so we call those binomials. 3x squared plus 2x plus 1 is a second degree. We call a second degree a quadratic. There are 3 terms, so it's a trinomial. 4x cubed, that's a third degree. We call that a cubic. There's only 1 term there, so this is another monomial. 9x to the fourth plus 11x is a fourth degree, sometimes referred to as a quartic. In this case, there are 2 terms, so this is a quartic binomial. And finally, just the number 5, that's a 0 degree. We call that a constant. Since there's only 1, it's a constant monomial. Let's classify some in terms of degree and number of terms. 3m cubed, that's a cubic monomial. Y squared minus 4y plus 8, There's 3 terms. It's a second degree, so we call it a quadratic trinomial. When we add polynomials, you can do it 2 ways. You can write them vertically, in which you would stack the like terms together and just add down, or horizontally, which you're kind of doing the vertical method in your head. You just don't necessarily write it that way. But let's start by writing it vertically. 4x squared plus 6x plus 7, and we're going to add to that 2x squared minus 9x plus 1. Notice the squared terms are together, the first degree terms are together, and then the constants are stacked. And then we just add down. 6x squared minus 3x plus 8. You did it horizontally, you'd end up with the same idea. Okay, let's try a little bit here. So in this case, I have 12m squareds, and I'm going to add to those 8m squareds. So that gives me 20m squareds. And then I'm going to add a constant of 4 and a constant of 5. So that's 9. Here I have 9w cubes and 1w cubed. That gives me 10w cubes. There is only one w squared term, so there's no like term with that guy. He just stays the same. And then finally, with a constant of negative 5 in the back for a cubic trinomial. Subtracting polynomials is a little more complicated because you're subtracting an entire polynomial, not just the individual monomial. So notice we've written the parentheses around the bottom term, so you can see that we're subtracting all 3 terms, not just that first 2x squared. So that becomes 4x squared, and we're going to subtract 2x squared from it. We have the 6 x's, and now minus 9x gives me positive 9x, so I end up adding my x's. And 7 minus a positive 1 is 7 minus 1 for 2x squared plus 15x plus 6. If we did it horizontally, we have 4x squared minus 2x squared gives me 2x squared. We have 6x minus a negative 9x, so that turns it into plus 9x or 15x. And finally, 7 minus 1 is 6. Here are a couple for you to try. If you want to pause the video and give it a shot. I get negative 8v cubed plus 13v squared minus 4v. And in the last example, I get negative 6x squared y plus 4.